Hi friends, I guess after every 15 minutes I'm going to have to start a new video because the software only allows 15-minute increments. But anyhow, we were on the top of example number 2 and we were talking about these two line segments, and we were discussing how although there are two different lengths, both total line segments represent 100%. And that's a little bit of a tough idea to wrap your head around, but I want you to think about it this way. So right now, there are 3 people in my house. So 100% of the people in my house equals 3 people. 100% of the people in your house might equal 4 or 5 people, right? So although there are different numbers of people in my house and your house, the total number of people in your house still represents 100%. So although these are two different lengths of line segment, the total of each represents 100%. Now what starts to get a little tricky is that if we look at our first line segment, the total of which is 2 inches, and the second line segment, the total of which is 4 inches, 100% of line segment 1 is equivalent to 50% of line segment 2. So that starts to get a little bit tricky, but we're not getting there quite yet. We're gonna stick to the simple stuff right now. So what they're asking you to do is to represent point A on line segment 1 as a percent of the total line segment. So as we can see that point A is 1 inch of 2 inches in this total line segment, so it's 1 over 2, 1 over 2, right, would equal 50 over 100, which equals 50%. So point A would represent 50% of the first line segment. If we look at the second line segment, point B is 1, 2, 3, 4. It represents one of the 4 line segments. Excuse me, not line segments, but intervals. One of the 4 intervals. So it would represent 1/4 of the total line segment. 1/4 would be equivalent to 25 over 100, which equals 25%. Okay. So if you do the try it on the bottom of the page, I'm going to give you a second to do that. And the question asks, which point represents 50% on the second line segment? Alright, so hopefully you had a moment to consider that. And if we look at the second line segment, point C is right in the middle. It's going to represent 50% of the total line segment. So if point B was 25%, point C is double that amount. It's going to be 50%. And each point on the line as we continue to the right is going to represent an additional 25% as this entire line segment has been divided into quarters, into fourths. Okay, so let's take a look quickly at example 3 before we move on to our classwork. So example 3, we're talking about the use of percent and mental math to find the length of a line segment. So our first line segment here, we're given, excuse me, we're given line segment CD represents 10% of the secondary line segment here in blue. So this CD represents 1/10 of this blue line segment here. So what that means is this is 1/10 of this entire line segment. So if this is 4 inches, line segment CD, what we can do is on the computer here, it's actually going to let me copy line segment CD. And so I'm going to copy it until I've reached the end of the blue line segment, which right now does not have a name, but we could name the line segment if we wanted. It could be line segment EF if we placed those letters at the end of the line. Okay, so we're almost done here. So this is 9 copies. And as you can see, I have not aligned them perfectly, so it's not going to line up perfectly, but I got pretty darn close. So if we were to add these all up, we have 4 inches for each green line segment, and we've copied 10 of those line segments. So 4 times 10 would equal 40 inches. So we could say our blue line segment is 40 inches long. And if we divided that by 12, we'd have 12 and 4, 36. We'd have 3 feet with 4 inches left over. So 3 feet and 4 inches would be that blue line segment. Okay, so all we did was we looked at our initial line segment, the green line segment CD, and we said how many copies of that can we place inside our second line segment. And we figured out it was 10. there'd be 40 inches in our blue line segment. Okay. Our second question asks us, and I'm going to flip to the second part of this example here. It says you can use percent in mental math to find the length of a line segment. If line segment EF represents 200%, what is the length of a line segment that is 100%? So you might say to yourself, well, if it's out of 100, what does 200% mean? And I want you to think about it. So if we had 200 over 100, we could reduce that to 2 over 1, which is equivalent to 2, the number 2. So 200% would be double 100%. So if 100% of the people in my house is 3 people, 200% of the people in my house would be 6 people. Okay? So this line segment, we're being asked to double it. We're being asked for 200% of this line segment. Okay, so drag copies of the blue line segment to explore. Okay, what is the length of a line segment that is 100%? So we're actually being asked for half of this, I'm sorry. So EF represents 200%, and we're being asked for 100%. So if 200% is 6 inches, we don't really even have to use these models, but we will. So half of that is going to be 3 inches, or 3 of these small blue line segments. Okay, let's flip over to our next part of the example. And I guess I should have said this earlier, but if you're looking at where it says capital C, capital D, and there's a line on top of both the letters, that means line segment. Okay, so if line segment CD represents 10%, what is the length of line segment that is 100%? So 4 inches, we said 4 times 10 is going to be 40 inches, or 3 feet and 4 inches. Okay, so EF represents 200%. What's the length of a line segment that's 100%? Half of 6 is 3, so 3 inches would represent 100% if EF represents 200%. What if EF represented 300%? We divide this by 3. So 100% of this, if this were 300%, would be 2 inches. Okay. So now, finally, if line segment CD represents 100%, what is the length of a line segment that is 25%? Explain. So what is a quarter of 4? Right, 1. So 25% of this would be 1 inch. All right, so that's the end of the examples. What I would like you guys to do, so hopefully you are still following along in your textbook, because that's what you should be doing. We just went through all the examples together, so we were on page 337, and now we should be heading towards page 338. What I'm going to have you do is I'm going to ask you to do numbers 2 through 11 on your own. So I'm going to ask you to pause the video, do numbers 2 through 11 on your own. When you've finished 2 through 11, I want you to restart the video. I'm going to do the corrections on screen, so you'll have the right answers. And then after that, I'm going to have you move on to the next page of classwork, but I want to make sure you're on the right track. So go ahead, do page 338, pause the video, come back when you're done for corrections. Alright, so I have gone ahead and placed the answers for page 338 on the screen, and we're going to go ahead and go over them together. So for number 1, we would use percent, right? So how can you represent a rate with 100 as a whole? We would use percent. So the percent is the number of hundredths that represent the part of the whole. So 19 over 100, 19%. 26 over 100, 26%. Okay. When we're writing a percent as a fraction, what number do you write as the whole or denominator? Write 100. When we're talking about percent, your denominator is always going to be 100. So why are tenths, fifths, fourths, and halves easy to express as percents? Those numbers are factors of 100. So tenths would be 10%, fifths would be 20%, fourths would be 25%, and halves would be 50%. So those are kind of benchmark percents that as we use percents more and more often, you're going to start to become really comfortable with those. They'll be like multiplication facts. You'll just know them. Okay. So why is a grid in example 1 a good way to represent a percent? And that's talking about a hundredths grid. It's good because each section represents 1/100th. Right. Okay, so if line segment CD in example 3 represents 100%, is the length of a line segment that is 300% longer or shorter than 4 inches? It's going to be longer. So 300% is going to be 3 times as large as whatever 100% is. Right. Okay, so in number 6, they're asking us to write the percent. So the pie chart there, the shaded portion is 40%. Number 7, the hundredths grid, the shaded portion is 7%. And 8 through 10, you guys have the work there. So we're going to multiply both the numerator and the denominator by 20 to get to a denominator of 100. We always want to end up getting to a denominator of 100 to express percent. Just like in unit rates, we always wanted to get to a denominator of 1. Now we always want to get to a denominator of 100. So we'll have 20% for 8, 30% for number 9, and 55% for number 10. Okay, so I'm going to allow you, at this point, to either continue practicing on page 339. So I will post the answers on here. If you want to do page 339 for additional practice, I'll post the answers. I'm also going to give you the option to do the assigned extra practice for this lesson, which is going to be your homework. Okay, so you either have the option, if you feel like you need more practice, you can do the practice in your book on page 339, and I will post the answers in this video so you can make corrections. Or if you feel like you've got it and you'd like to move on to the homework, I'm posting that to your Google Classroom. So it's going to be topic 6, lesson 1, 6-1, math, capital X, L, right, extra learning practice. This is something that we usually used for test preparation in the past, but I'm going to start using it for your homework because it's automatically graded and corrected, so you can see instantly what you got wrong. Okay, and then I'll have that data the next day so we can see what we need to work on. Okay, so please email me with any questions, concerns, things that you'd like to see done differently. I know that over the course of time, the way that we conduct this class is probably going to change. I appreciate you willing to try something new and being flexible. And yeah, I hope you guys are doing well. I miss you all, and I'll see you tomorrow for your next lesson. All right, bye-bye.